Hey guys, welcome to Shekar YouTube channel. Today we are going to discuss about next two important law, Kirchhoff voltage law. So simply we can say that KVL. First, let's see the definition of the Kirchhoff voltage law. So it states that the algebraic sum of voltage drops plus the voltage sources in closed circuit is equal to zero. So this statement is saying that sum of the voltage drops plus and voltage sources in a closed circuit is equal to zero. So this is a statement you are supposed to write in the examination. So in the exam you have to write this is the definition, and let's see the circuit. Okay, this is a closed path. So this is the closed path which is having resistances R1, R2, R3, and what are the voltage sources? E1 and E2. So this is the closed circuit. So we have to apply KVL for only closed circuit. So the statement is saying that it states that the algebraic sum of the voltage drops. So sum of the voltage drops means this is the voltage drop R1, R2, R3. So when the current is coming from this side, so the battery gives the current I1. When this I1 current flows through the R1, the product of I into R gives the voltage drop. So voltage drop across R1, voltage drop across R2, voltage drop across R3. These are the voltage drops. These are the voltage drops. Plus voltage sources. What are the voltage sources in the circuit? E1 is the one voltage source. E2 is the second voltage source. So the algebraic sum of voltage sources plus voltage drops is equal to zero. Where it is zero? In a closed circuit, closed path. So therefore here closed path is A, B, C, D, E. So what are these A, B, C, D's? These are the nodes. So nodes in the circuit. So node A, node B, node C, node D, node A. So this is a closed path, closed circuit. Now we have to apply KVL to this circuit. So now let us see. So there's one more important point. So before applying this KVL to the closed path, we have to remember voltage signs. So voltage signs means how the voltage signs will be taken, positive, negative. So that. So for that, so this is when the current is flowing from higher potential to lower potential. Let us say this is A and this is B. The current is moving from A to B. Then voltage source is positive to negative, for example. So it means we are moving from positive to negative. So we can say that fall in voltage. Fall in voltage nothing but, so drop across this resistor. You are we have to take minus I into R. It means minus I into R. This is the drop. Similarly, again we are moving from A to B, but the battery symbol are reverse. So the battery signs are changed. Here positive negative we are moving, positive to negative. So we are again our direction is A to B we are moving, but battery is reverse. In this case, so we are moving from here negative to positive. Then we can say rise in voltage. Therefore, we have to take IR drop positive. So this is very important in Kirchhoff voltage law, taking the voltage signs. Okay. Then now let's see how this circuit when apply this Kirchhoff voltage law. Okay. Apply KVL for A, B, C, D, A. A, B, C, D, A. Again, why you are coming to A? So we must take closed path. This is a closed path. We should not come stop here. We should not stop here because we have to follow the procedure. So next, now we are moving A to B. So A to B, what are the elements connected? R1, R2, R3. So how to take this sign? So this battery is giving I1 current. So I1 is moving from A to B. So as I said here, so you have to apply this condition here. So minus I1 into R1. I1 into R1 nothing but we are moving from A to B. So obviously we have to take this is a positive and negative. This is a battery direction, and also we are assumed that we are moving from A to B. We can also move B to A, but in this case we have assumed that we have moving from A to B. So battery voltage also same. So positive to negative. So the I1 current is coming like this, and we are also moving from positive to negative. So when we are moving from positive to negative, what is the IR drop? What I told here, when moving from positive to negative, we have to take minus IR drop. So therefore, here we have taken minus I1 into R1. Clear? Next, similar I1 is flowing through R2 also. Again, positive to negative we are moving. Therefore, minus I1 R2. And next, again, this I1 flows R3 also. So positive to negative again we are moving. So therefore, this I1 into R3 and I1 into R3. Again, we are A to B is done. Okay. So A2 is done. Next, C to D. C, A, B, C, B, C. So B to C, what is there? B to C, only voltage source is there. So how to take this voltage sign? Again, we are moving from positive to negative. Therefore, again, this voltage sign also we have to take negative. So minus E2. Again, C to D. C to D, nothing is there. No battery source, no elements, no resistor, nothing. So leave it. Again, D to A. D to A, we are moving like this. So negative to positive we are moving. So when moving negative to positive, what you have to take voltage sign will be either IR drop or voltage, whatever it may be. You have to take plus symbol. So therefore, negative to positive, then E1 will be the plus. Therefore, E1 you have to take plus symbol is equal to 0. So this is the statements. Algebraic sum of the voltage drops plus voltage sources is equal to 0. So we can write sigma V plus IR is equal to 0 in simple sentence. So this is the expression for voltage law. So next, you take if you take minus as common, minus I1 R1 plus I1 R2 plus I1 R3 minus E2 plus E1 is equal to 0. If just rearrange this equation, and E1 minus E2 is equal to I1 R1 plus I1 R2 plus I1 R3. Take I1 common. E1 minus E2 is equal to I1 into R1 plus R2 plus R3. So this is the Kirchhoff voltage law, how generally we apply. So we will be quoting a question like that. Explain about Kirchhoff voltage law, or state and explain about Kirchhoff voltage law. Then you have to start from here, and you have to state the statement first, and after that draw the circuit diagram and explain like this till this point. So this will be the only statement and explanation, and I hope you understand this concept. Okay, thank you.